Hello everyone, welcome back. In this video, we will learn about some drug-drug interaction related terminology and we'll also touch base on some concepts about the enzyme or transporter inhibition and inductions. So pharmacokinetic drug-drug interactions can occur when one drug has a potential to inhibit or induce an enzyme or transporter that is critical for the pharmacokinetic of some other drug. And when these two drugs are sort of co-administered. So the drug that has the potential to inhibit or induce a protein, whether it's enzyme or transporter, is called the perpetrator of the DDI. And the drug that is a substrate of the same enzyme or transporter is called the victim. So the victim usually uses this specific enzyme or transporter for its metabolism or elimination. And the perpetrator basically inhibit or induce the same enzyme. So how do we usually model it? So for the substrate drug model, we need to define the drug metabolism or transporter processes specific to the enzyme or transporter in question. And for the perpetrator drug, we need to define that inhibition or induction process. And then this two drugs can be co-administered in a PBPK type of model, and we can evaluate the pharmacokinetic changes in the substrate. And these interactions can be reversible inhibition, which can be either competitive, uncompetitive, mixed, or non-competitive. Or it could be irreversible, which is also called time dependent, or more of a like mechanistic inhibition. It could be either induction as well. So the data for this induction or inhibition processes could come from most likely it usually comes from the in vitro studies, which could be obtained through the literature search, or if it's a new drug, it may need some in vitro studies, and then you need to qualify your inhibition or any induction processes in vivo maybe. So now let's move on to the next slide. I'm not sure. So this figure shows common mechanisms of the drug-drug interactions. A marketed drug can be either a victim or a perpetrator, as well as the new drug that you are interested in to assess the DDI with one of the marketed drug could be a victim or a perpetrator. So your new drug can be either the victim, as I said earlier, or it could be a perpetrator. If it's a perpetrator, it's basically the different types of inhibition or induction processes that I just described in the previous slide. So we'll go over each one of these processes in a little bit details. You may remember this from earlier college level courses. So let's move on. Okay. So the first one is a reversible competitive inhibition. In this type of inhibition, the inhibitor, which is this I, binds reversibly to the enzyme, and it competes with the substrate for basically the free enzyme. So in case of reversible inhibition, high substrate concentrations can overcome this inhibition. So if we describe the kinetic by using our standard Michaelis-Menten equation, in this type of reversible competitive inhibition, basically the Km increases due to the inhibition, and thus the rate of the rate of the metabolism basically decreases. In this case, the Vmax remains unchanged. On the other side, for the reversible uncompetitive inhibition, the inhibitor binds to the enzyme substrate complex, and binding of this inhibitor to the enzyme substrate complex is also reversible. This kind of inhibition decreases the Km, if you look at this equation, as well as it decreases the Vmax, and apparently it decreases the rate of metabolism or rate of process if it's a transporter related. So that's about that. Let me move on to the next slide. Okay. So in a reversible mixed inhibition, the inhibitor binds reversibly to the enzyme and to the complex, and these affinities are different, and the dissociation constants are different. So this inhibitor binding site is different from substrate binding site on the enzyme molecule. So in this kind of inhibition, the Km changes, and the changes, whether it increases or decreases, depends on these affinities. And the Vmax usually goes down, it decreases, and apparently your rate of your process is decreased. And the reversible non-competitive inhibition is a type of a mixed inhibition where these affinities are sort of same. So there's only one constant, Ki, which describes Ki for uncompetitive inhibition, and the same for competitive inhibition. Okay. So next, okay. So in the irreversible, or also known as time-dependent or mechanism-based inactivation, in this type of inhibition, the rate of inhibition usually follows a hyperbolic kinetic pattern, so sort of our Emax kind of model. And generally this kind of inhibition has a slow onset, but potentially its effects are more profound than those of the reversible inhibition as the time goes on. So here, if we look at this kind of process, it's sort of an indirect response model where we have to take into the account for the enzyme synthesis and enzyme degradation, because the recovery in this kind of inhibition is only due to the enzyme synthesis. So if you take the first order enzyme synthesis and zero order degradation, and you described your inactivation process using sort of an Emax function. Here the rate of inactivation is so K inact is sort of a Vmax type of parameter, which is the maximum rate of inactivation, and Ki is sort of the EC50 kind of parameter, which is the concentration at which the inactivation rate is half the maximal. And this affects basically the enzyme, the rate of enzyme related metabolism basically. So that's about the irreversible inhibition. If we move on to the next slide. Okay, the induction, enzyme induction or the transporter induction. I haven't really seen transporter induction kind of models yet. So most common is the enzyme induction. This usually occurs due to the increased synthesis of the enzyme, and in very rare cases due to the degradation of the decreased degradation. And it also is described by sort of Emax kind of function, where you have Emax and EC50 parameters for your induction effect. And all these types of models are built in within the PKSim. You have to just select which type of process you have based on either in vitro studies or what you find in the literature, and you define your parameters. So now these are all the kinds of processes. If we move on to how do we usually link these two types of processes, basically you have your substrate PBPK model and your perpetrator PBPK model, and you have all your metabolism, all the processes in place, and then you link these two models basically in the PBPK PKSim software, and you describe all the mechanisms and just describe the dosing scenarios, and then you simulate your interactions, and then evaluate the difference in your exposure parameters. So that's all I had for this lecture. In the next video, we will demonstrate drug-drug interaction simulation in the PKSim. Thank you very much.